Now let us discuss one more problem in the form px plus q dx divided by root of x square plus bx plus c. That means linear divided by root quadratic. That is integral of 5x plus 3 divided by root of x square plus 4x plus 10. As we discussed, we express the numerator 5x plus 3 as a constant a into derivative of denominator plus b. Compare coefficient of x on either sides. 5 is equal to 2a. So a is equal to 5 by 2. Put x is equal to 0 in that. So the left side is 3. That is equal to 4a plus b. Simplifying, b is equal to minus 7. Now the problem. Integral 5x plus 3 by root of x square plus 4x plus 10 is equal to 5 by 2 into 2x plus 4 minus 7. The numerator is split as 5 by 2 into 2x plus 4 minus 7 by x square plus 4x plus 10. Splitting the numerator, that is 5 by 2 into 2x plus 4 by denominator minus 7 divided by the same denominator. And first part of that problem is take u is equal to x square plus 4x plus 10 and derivative of that one is 2x plus 4 dx. That is our numerator. So the first part becomes 5 by 2 into integral du by root u minus 7 by completing the square of the denominator dx divided by x plus 2 the whole square minus 4 plus 10. Now the answer of this one is 5 by 2 into root u minus 7 into integral dx divided by root of x plus 2 the whole square plus root 6 the whole square. So the final answer is 5 into root of x square plus 4x plus 10 minus 7 into log of x plus 2 plus root of x plus 2 the whole square plus root 6 the whole square. The last part is same as the denominator of the given function that you can simplify. We have already discussed the integrals of the form dx by x square plus bx plus c. Let us revise that. We have to convert that one into any one of these three forms: integral dx by x square minus a square, integral dx by x square plus a square, or integral dx divided by a square minus x square by completing the square or converting the denominator into the sum or difference of two perfect squares. And another problem, and the second type of that one is integral linear by quadratic, that is px plus q dx by x square plus bx plus c. And here you put the numerator px plus q as a into derivative of denominator plus b. Find a and b and split the numerator and solve that one using any one of our previous result. And in this case the first part is always log of denominator, a constant into log of denominator. And the third type of question in the previous section is integral dx by root of x square plus bx plus c. We discussed we have to split the function inside the square root as either a square plus x square or a square minus a square or a square minus x square and apply the standard result for that that we discussed. And the last type of that one is integral px plus q dx by root of ax square plus bx plus c. Similar to the previous one, take px plus q is equal to a into d by dx of the function inside the square root, that is d by dx of x square plus bx plus c plus b. Find a and b by comparing the coefficient of x on either side and putting x is equal to 0 in this expression and split the numerator, then integrate. Here the first part is always 2 root u, root of 1 by root u, and the integral of that one is always 2 root u, and the second part you can find it by splitting the function inside the square root. Next we are going to discuss a very important section in integration, that is integration by partial fraction. Integration by partial fraction. Look this term partial fraction. And what is meant by partial fraction of a compound expression? Look this expression. Leave that integration part now. How can we split this one into corresponding its factors. That is 3x minus 2 by x plus 1, x minus 2 and x plus 3. Here the power of the denominator is 3 because x cube, the cube 3 is the power of the denominator. We cannot apply this one linear by quadratic form. And also this is a proper fraction because the power of the numerator is less than the power of the denominator. So we can split this one into their factors. For that, let us adopt the very first method of partial fraction. There are three methods here, of which we are going to discuss the first method of partial fraction. This portion is very important also. To convert this one into their linear factors, write this expression as a divided by the first factor, b divided by the second one, and c divided by the third factor in the denominator. No problem, you can select either x plus 1 or x minus 2 or x plus 3 as their corresponding factors, no problem. But you split like this, a by, b by, c by, if the denominators are linear factors. This one is linear, this is also linear, this one is also linear, and this is method 1. And to find the value of a, b and c, let us take the LCM of the right hand side. The left side is same as this one and the right side is take x plus 1, x minus 2 and x plus 3 as LCM, and a along with x minus 2 and x plus 3, b with x plus 1 and x plus 3, and c with x plus 1 and x minus 2. Now these two fractions are equal, so we can compare their corresponding numerators. That means the numerator of the left side is 3x minus 2, which is equal to the numerator of the right side is a into x minus 2 into x plus 3 plus b into x plus 1 into x plus 3 plus c into x plus 1 into x minus 2. And similar to one of our previous problem, we can find the value of a, b and c. A, b and c by substituting some values into this one. Here you substitute some suitable values for ax, for getting the constant values a, b and c. Here you can see one factor is x minus 2 in this one, x minus 2 is repeating in this function twice. So let us assume x is equal to 2, because when x is equal to 2, the c term will be 0 and a term will be 0. So put x is equal to 2 in this one. The left side is 3 into 2 minus 2, that is 4. 6 minus 2 is 4, that is a into 0 plus b into 2 plus 1 into 2 plus 3, that is 5 into 3, 15. So b into 15 plus c into 0 implies b is equal to 4 by 15. So we got the one of the constant b equal to 4 by 15. And next we have to substitute. See the factors in this one. One term is x plus 1 and another term is x plus 1 in this factor. So put x is equal to minus 1 in this one. That two terms will be cancelled. So when x is equal to minus 1, the left side is 3 into minus 1 minus 2, that is minus 5. That is minus 5 is equal to a into minus 3 into 2 plus b into 0 plus a into 0 implies the value of a is equal to 5 by 6. Similarly, you put x is equal to minus 3 in this one. The left side is 3 into minus 3 minus 2. That is minus 11 is equal to the a along with minus 3. So this part will be 0, this part will be 0, and c with the minus 3 plus 1, minus 3 minus 2, that value is equal to minus 2 into minus 5. So the value of c is equal to minus 11 divided by 10. So the use of this one is you can split this 3x minus 2 by x plus 1, x minus 2 into x plus 3 as their corresponding factors. That corresponding factors, the value of a is 5 by 6 by one factor, 4 by 15 by another factor, minus 11 by 10 by another factor. So the previous one is a compound expression. Now we got their corresponding linear factors like this. To integrate that compound expression, so let us come to that integration. To integrate the 3x minus 2 by that 3 factors in the denominator, let us integrate the corresponding factors. Integral 5 by 6 by x plus 1, integral 4 by 15 by x minus 2, minus integral 11 by 10 divided by x plus 3. And we know the integral of a linear function in denominator 1 by x log x. So 1 by x plus 1 log x plus 1. So the first one is 5 by 6 log x plus 1, 4 by 15 by x minus 2, 4 by 15 log x minus 2, minus 11 by 10 divided by x plus 3 is minus 11 by 10 log x plus 3 plus c. Listen, and here this is the first method of integration by partial fraction. If the denominators are linear factors, you can split this one into their corresponding factors by adopting the constant values a, b and c, like that, and split this, we can integrate. Otherwise it is linear by cubic. There is no standard result for that. For any function involving the denominator with power more than 2, we can adopt partial fraction. This is the first method of partial fraction. Let us consider one more problem based on the same method. I mean the first method of partial fraction. Here the problem is x divided by x minus 1, x minus 2 and x minus 3. The denominator is a cubic degree equation and it is given in their corresponding linear factors. So let us convert that x by x minus 1, x minus 2, x minus 3 as a by x minus 1, b by x minus 2 plus c by x minus 3. Taking the LCM in the right hand side, a into x minus 1, x minus 2 into x minus 3, b into x minus 1, x minus 3 plus c into x minus 1, x minus 2, and you compare these two equations. I mean the expression in left side and right side, both denominators are same, so you can compare the numerator. X is equal to a into x minus 2 x minus 3 plus b into x minus 1 x minus 3 plus c into x minus 1 x minus 2. Here the value of ABC, the method for getting the value of ABC are very simple, because the factors are x minus 1, x minus 2 and x minus 3. So put x is equal to 1 in this. Left side is 1, a into 1 minus 2 minus 1, 1 minus 3 minus 2, and b into 0 and c into 0. So the value of a is equal to 1 divided by 2. Similarly put x is equal to 2. Left side is 2, a into 0, b into 2 minus 1, 1, 2 minus 3 minus 1 plus c into 0. So the value of b is minus 2. Put x is equal to 3 in this. Left side is 3. Left side is 3. A into 0 plus b into 0 plus c into 3 minus 1, 3 minus 2. That is 2 into 1. So the value of c is equal to 3 divided by 2. So to integrate this x divided by x minus 1, x minus 2, x minus 3, you simply integrate their corresponding factors, that is a by 1 by 2 by x minus 1 and b minus 2 by x minus 2 and c 3 by 2 by x minus 3. 1 by x, the right hand side is the form 1 by x, integral dx by x form, that is log. 1 by linear is always log. So half log x minus 1 minus 2 log x minus 2 plus 3 by 2 log x minus 3 plus c.